Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today we'll be going over a physics pulley problem. So I'll just explain it really quickly. Over here we have mass m that is on a frictionless surface. It is connected by a string that is attached to a pulley that is attached to mass n. Mass n is falling down and it has the weight of 8 kilograms. The acceleration of n is 3.2 meters per second squared in the positive direction, and you're looking for the value of m in kilograms. So if you'd like to give it a shot, just pause the video. Otherwise, I will be starting. So we know that m is on a frictionless surface, so we can also just right now start by drawing the free body diagrams of both. So for our mass m, we can kind of ignore the force of gravity and force of normal since we know they cancel out. We're mainly concerned with just its horizontal components. So we know that it's on a frictionless surface, which means we can't possibly have force of friction, which means the only direction a force is being enacted on is from this string. So here, the only force enacted is force tension. Now, we know that the mass n is accelerating at 3.2 meters per second squared. Now, since they're both connected by a string, they're both accelerating at the same rate. It's as if you were taking one object that was glued to another object and you're just moving them back and forth, they'd accelerate at the same rate. So the acceleration of mass m would also be equal to 3.2 meters per second squared. Now, let's look at our mass n. Mass n is accelerating downwards, which means it has a force of gravity acting downwards, and its force net is also acting downwards. So let's just draw a quick free body diagram of n. Now, if it's accelerating downwards, it means whatever the force of gravity, it means force of gravity has to be greater than its opposing vertical component. Now, this mass n is connected to a string, which means we know that the upwards vertical component has to be force of tension. So Ft and Fg, such as force of gravity, has to be greater than force of tension. And we also know that Fnet is acting in the downwards direction. So now that we have this information, we can begin calculating. So we know that we can calculate the Fnet of mass n, since Fnet is equal to mass times acceleration. Now, by finding our force of tension here, we can also find the force of tension here, since they're both in the same system. So by finding force of tension, we'll be able to find out the Fnet of mass m, and with acceleration, we'll be able to find the mass m. So back to our force net of n. So we have Fnet equals to ma, where the mass is equal to 8 kilograms, and acceleration is equal to 3.2 meters per second squared. Now, let's just use our calculator to solve that. And we get 25.6 newtons. Now, as this mass is traveling downwards, it has an Fnet of 25.6 newtons. However, this Fnet is equal to its force of gravity component, which we know is greater than force of tension since it's accelerating downwards. So we know Fnet is equal to force of gravity subtracted by force of tension. Now, we want to isolate for force of tension. So we'd add force of tension to this side and subtract F net. So our finally rearranged equation would be F tension equals to force of gravity minus F net. Now, what's force of gravity? Well, force of gravity is equal to mass times g. G is just simply equal to 9.81. It's our gravitational constant. So, with mass of 8, we can solve for our Fg. Fg is equal to 8 times 9.81. Now, I'm not using units right now. That's not a great thing, so don't take after me. Remember your units. Now, we can calculate this. And that will give us 78.48 newtons. Now, going back to this equation, if we substitute force of gravity subtracted by our F net, we'll be able to find our force tension. So we'll have force of gravity, which is 78.48 newtons, subtracted by our F net, 25.6 newtons, and we will get 52.88 newtons as our force of tension. Now, since 52.88 newtons is our force of tension, we can go back to here and say that the only force acting on mass m is the force of tension, which, since they are connected by the same string, the Ft here will equal to 52.88 newtons. Now, since we know that the vertical components are balanced, since there's nothing happening vertically, we know that F net has to be equal to 52.88. Now, since F net is equal to this, we can use that to calculate our mass. Since F net is equal to mass times acceleration, we know acceleration to be 3.2 meters per second squared, so we isolate for m by dividing by a, canceling out. So m is equal to F net over a, where F net equals to 52.88 and a is equal to 3.2. If you'd like to calculate that, mass would equal to 16.525 kilograms. Now, we don't really have any significant digits in our question right here, but if you did encounter significant digits, you'd put it in the correct digits. For example, let's say 3.2, so let's just put to the whole number. Our mass would be 17 kilograms. That is all for me today. If you have any questions, please let me know. Thanks for studying with me.